Welcome to YQ Academy, SQL Interview Questions and Answers. 1. What is the difference between stored procedure and function? 1. Usage. Stored procedures are primarily used to encapsulate and execute a series of database operations or tasks. They can be called from an application or executed directly within the database. Functions are primarily used to compute and return a specific value or result set based on the provided input parameters. They are often used in select statements, expressions, or as part of other functions. 2. Return type. Stored procedures can return multiple result sets or no result set at all. They can also modify the data in the database through DML data manipulation language statements like insert, update, or delete. Functions always return a value. They can return a scalar value, e.g., a number, string, or date, or a table of values. Functions cannot modify data in the database directly. 3. Input/output parameters. Stored procedures can have input parameters that allow values to be passed into the procedure when it is called. They can also have output parameters that return values back to the calling program. Functions can have input parameters that are used to provide values for computation or filtering. These parameters are passed when the function is called. 4. Transaction management. Stored procedures can participate in database transactions, allowing for better control over data integrity and consistency. They can be used to define atomic and reusable operations. Functions are typically deterministic, meaning that for a given set of input parameters, they always produce the same output. This property is crucial for predictable query results. 5. Code reusability. Stored procedures can be created once and then invoked from multiple locations or applications, promoting code reuse and centralizing business logic. Functions can be categorized as either scalar functions or table-valued functions. Scalar functions return a single value, while table-valued functions return a table of values. 2. What is the difference between clustered index and non-clustered index? A. Clustered index. A clustered index determines the physical order of data in a table. Each table can have only one clustered index, and it determines the way data is stored on disk. 1. Physical order. A clustered index organizes the data in the table based on the indexed columns. The data rows are physically sorted in the same order as the clustered index. 2. Table restructuring. Creating a clustered index on a table reorganizes the data on disk to match the index order. This process is known as index rebuilding and can be time-consuming for large tables. 3. Searching efficiency. Due to the physical order of data, the clustered index provides efficient searching when queries involve range scans or when retrieving data in the order of the indexed columns. 4. Key columns. A clustered index is typically created on the primary key columns of a table. If a primary key constraint is defined on a table, a clustered index is automatically created unless explicitly specified otherwise. 5. Data modification impact. As the data is physically ordered based on the clustered index, any updates, inserts, or deletes that affect the indexed columns may cause data movement and potentially impact the performance of such operations. Non-clustered index. A non-clustered index is a separate structure that contains a sorted copy of selected columns from a table. And like a clustered index, a table can have multiple non-clustered indexes. 1. Logical order. A non-clustered index does not dictate the physical order of data in the table. Instead, it creates a separate structure that references the data pages containing the indexed columns. 2. Searching efficiency. Non-clustered indexes provide efficient searching for queries that involve the indexed columns or queries that include the indexed columns in the where or join clauses. 3. Included columns. In addition to the indexed columns, a non-clustered index can also include additional non-key columns, known as included columns. Including frequently accessed columns in the index can improve query performance by covering more data. 4. Data modification impact. Non-clustered indexes have less impact on data modification operations compared to clustered indexes. Updates, inserts, or deletes only require changes to the index structure rather than physically reordering the data. 5. Table size. Non-clustered indexes require additional storage space since they store a copy of the indexed columns and the necessary pointers to the actual data rows. 3. What is the difference between truncate and delete commands? 1. Data removal. Truncate removes all rows from a table, resulting in an empty table. It is a DDL data definition language statement. Delete removes specific rows from a table based on the specified where condition. It is a DML data manipulation language statement. 2. Transaction log. Truncate operations are typically minimally logged, which means they can be faster than delete statements for large tables. Truncate operations cannot be rolled back. Delete operations are fully logged, which means they generate a log entry for each deleted row. Delete operations can be rolled back using transaction control statements, e.g., rollback. 3. Identity values. Truncate resets any identity or auto-increment columns in the table to their initial seed value. Delete does not reset identity or auto-increment columns in the table. If you delete rows and then insert new rows, the identity values will continue from where they left off. 4. Data integrity. Truncate does not fire any triggers associated with the table and does not enforce referential integrity constraints. It is a faster operation but lacks some of the finer control provided by delete. Delete fires triggers associated with the table and enforces referential integrity constraints defined on the table. Provides more control over the delete process, allowing conditions and constraints to be considered. 5. Table structure. Truncate retains the table structure, including indexes, constraints, and permissions. It essentially removes all the data but keeps the table intact. Delete does not remove the table structure, indexes, or permissions. Only removes the specific rows that meet the criteria specified in the where clause. 4. What is the difference between where clause and having clause? 1. Usage. The where clause is primarily used in select, update, and delete statements to filter rows from a table before the action is performed. The having clause is used in select statements that include aggregate functions and group by to filter groups of rows. 2. Filtering rows. The where clause specifies the conditions that each row must satisfy to be included in the query result. It allows you to specify logical operators and, or, not, and comparison operators equal, less than, greater than, etc. to create complex conditions. Filtering groups. The having clause specifies the conditions that a group must satisfy to be included in the query result. It allows you to filter based on aggregate function results, e.g., sum, count, or column values. 3. Table columns. The where clause operates on table columns and compares their values against the specified conditions. Grouped columns. The having clause operates on grouped columns or the results of aggregate functions. 4. Aggregate functions. In general, aggregate functions sum, count, avg, etc. cannot be directly used in the where clause. However, you can use them with subqueries or in conjunction with the having clause. The having clause can include aggregate functions and compare their results against the specified conditions. 5. Applied before grouping. The where clause filters rows before any grouping or aggregation is applied to the data. Applied after grouping. The having clause filters groups of rows after the data is grouped and aggregate functions are applied. It filters the result set based on the aggregated values. 5. What is the difference between primary key and unique key? 1. Uniqueness. A primary key ensures that each value in the key columns is unique and cannot be duplicated within the table. No two rows can have the same primary key value. A unique key ensures that each value in the key columns is unique within the table, just like a primary key. No two rows can have the same unique key value. 2. Null values. Primary key columns do not allow null values. Each row must have a non-null value in the primary key columns. Unique key columns allow null values. Each row can have a null value in the unique key columns, but if a non-null value is present, it must be unique. 3. Table constraint. A primary key is a table-level constraint that can span one or multiple columns. It enforces the uniqueness and non-nullability of the key columns for the entire table. A unique key is a table-level constraint that can span one or multiple columns. It enforces the uniqueness of the key columns within the table. 4. Relationships. Primary keys are commonly used to establish relationships between tables. In a one-to-many relationship, the primary key of the one-side table becomes a foreign key in the many-side table. Unique keys can be used to enforce uniqueness in columns that are not primary keys and are involved in relationships between tables. They can act as candidate keys or alternate keys. 5. Indexed. By default, a primary key is automatically indexed, which provides faster data retrieval and ensures efficient enforcement of uniqueness. Like primary keys, unique keys are automatically indexed by default to enhance data retrieval performance and enforce uniqueness efficiently. This is the end of our SQL interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.